Guys, here we go into chapter 3. So section 1, solve linear systems by graphing. So first off, we have to think, what is a linear system? And you all know what graphing is. So we're going to solve by graphing. So let's talk about some vocab you need to know. Write these down. System of equations. This is at least two equations. So if I write down two equations, okay, like y equals 2x and y equals 3x plus 1. Whatever two equations I write down, that is a system of equations. What are you trying to find? You're trying to find a solution to the whole system, not just this one, but a solution to the whole system. What does that mean? A solution to a system is an ordered pair that satisfies both equations. So think of one ordered pair that satisfies both. Now you can't just look at those and find out. You have to actually graph or do some other options that we have. Okay? What makes both of these true? Okay, I can find out plenty that makes this true, plenty that makes this true, but what makes both of them true at the same time? That's what we call a solution to the system. Now, what I'm going to ask you to do is classify this system. This system right here, or any system I give you, is either going to be consistent or inconsistent. What does consistent mean? It has at least one solution. Could be one, could be many. Inconsistent system has no solutions to it. That's kind of easy. So if there's like, oh, no solutions, then it's inconsistent. Now, next, it's either going to be independent or dependent if it's consistent. So consistent means there's at least one solution. So then you have options under that. You can say, okay, well, this consistent system is independent because it has only or exactly one solution. If this thing had one solution only, it would be independent. If this system has infinitely many solutions, then it would be called dependent. So know these four terms and know how to use them. Alright, when I say classify, that's when you'll write these things down. Okay? So there's your vocab. Let's get started. Example 1, it says graph the linear system. That's our method of solving right now. So what I do is, that's standard form, right? ax plus by equals c. I like to find my intercepts. 0 comma something, there is my y-intercept, and something comma 0, there's my x-intercept. So if I plug in 0 for x, put a 0 right here, that's nothing, plus y equals 8. Well then, so 0 plus y equals 8. Then we got y equals 8. So when you plug in 0 for x, you get y equals 8. When you plug in 0 for y, put a 0 right here, so 4x plus 0 equals 8. That's nothing, so divide by 4. X equals 2. So there you go. Look how quick that was. Instead of putting slope intercept, excuse me, what you could do, I mean, this is quicker, I think. Plug in 0 for x, 0 for y, get 2 coordinates. Those are your intercepts. Plot those. Okay. You can take a moment. I'm gonna do a better one. But 0, 8, I'll just put up here. 2, 0, we'll just put right here. There'll be a line that looks like this. Okay. Then we go to our second equation. Once again, it's in standard form, so I'm like, all right, I'm going to plug in 0 for x and get a y. What's my y? If I put 0 right here, that becomes negative 3y equals 18, right? If that's nothing. So divide by negative 3 and get y is equal to negative 6. So 0 comma negative 6. 0 comma negative 6. We'll just say that's down here somewhere. Okay? And then you plug in 0 for the y value, right? Plug in 0 for x, get a number. Plug in 0 for y right here. That's nothing right there. So 2x equals 18 because that's nothing. So 2x equals 18. X equals 9. So 9, 0. So that is over here somewhere. Okay, draw a line. This is a rough sketch. You guys know that. Never do this, alright? But when you do that, you see what happens? There is where it crosses right here. There's an intersection that happens right there. Guess what that is? That intersection they both have in common. That coordinate right here, they both have this coordinate in common. That is your solution. Whatever coordinate they have in common is your solution. Okay? So let me show you a better graph on this. Here's a better graph. Okay, if you do it nice, and you have to do these really nice, because if not, if you do it sloppy, you won't get this number right here. You'll be like, ooh, it's up here. No, it's not. Alright, so by graphing both equations, they say appear because if you do it sloppy, it's going to appear somewhere else. Okay, at 3, -4. Alright, you can check this algebraically. So that's your solution, but you have to check it because sometimes you're just a little bit off. So plug in 3 and for x, -4 for y, and get 8 = 8. That checks out. That means 3, -4 is a solution to this equation, the first equation. What about the second equation? Put in x is 3, y is -4, and get 18 = 18, which is, it means this 3, -4 works for the first one and for the second one, which means it's a solution to the whole system. Okay, there it is. That's how you find your solution to the system.